students, I hope you all are safe in the pandemic. Now let us start today's lecture of class 10 chapter 2 polynomial. In my last lecture I have discussed about the polynomial types of polynomials. Please let us recall the types of polynomial. What is polynomial? Polynomial is the algebraic expressions in which the variables have degree. If the variable is of degree 1, then we say that this is linear polynomials. If the variable of degree 2, then we say that this is linear polynomials. Variable of degree 1. Here the x is the variable and its highest degree of this algebraic expressions is 1. Then this is called linear polynomials. Then zero polynomials means constant polynomials means the polynomial in which the degree of the variable is 0. Suppose 5, 3, a, b, all these are constant polynomials. Here the variable of degree 0. This means 5 plus x to the power 0. Then third, this is quadratic polynomials. Quadratic polynomial is the polynomial of degree 2. Polynomial is of degree 2. Suppose I say fx is equal to ax square plus bx plus c. This is called the quadratic polynomials. Here the degree of the polynomial is 2, means here x is the variable, highest degree of x is 2, hence it is called the quadratic polynomials. Then next, cubic polynomial. Cubic polynomial is the polynomial of degree 3. Then fourth is called the cubic polynomial. This is just recall you about the polynomials. Please students, follow my classes regularly. I hope you should not need any extra maths classes. Cubic polynomials means the polynomial of degree 3. Fx is equal to ax cube plus bx square plus cx plus d. This is called the cubic polynomials. Then biquadratic polynomials means the polynomial of degree 4. Biquadratic polynomial means the polynomial of degree 4. Here the highest power of the variable is 4. This is ax fourth plus bx cube plus cx square plus dx plus e. This is called the biquadratic polynomial. Now let us discuss about what do you mean by value of the polynomials. If fx is, let fx be a polynomial. Now let fx be a polynomial. Fx is equal to 3x square plus 4x plus 9. Then here the value of the polynomial means, suppose we have to find out the value of the polynomial when x equal to alpha. Then f of alpha is equal to 3 into, in place of x we write alpha square plus 4 into alpha plus 9. Then this is called the value of the polynomials at x equal to alpha. Suppose we say x equal to 5. Then f at 5 means value of the polynomial at 5. This is 3 into 5 square plus 4 into 5 plus 9. This is equal to 75 plus 20 plus 9, which is equal to 104. This is called the value of the polynomial at x equal to 5. Then when the fx, if we say fx is equal to 0, when x equal to alpha, then alpha is called 0 of the polynomial. Suppose here, now take another examples for if fx is equal to 3x square minus 6x plus 2 is equal to 0. Then in this case, find if we solve this, factorize this, this is middle factor factorizations, then this is minus 5x, sorry, 3x square minus 5x plus 2 is equal to 0. Use the middle factor factorizations to solve this, to factorize this. Then 5x can be split into two parts as minus 3x minus 2x. Please students recall the middle factor factorizations. Here 2 minus 2 taken common, this is x minus 1 is equal to 0. X minus 1 is common, x minus 1 into 3x minus 2 is equal to 0. Here if x equal to 1 or another value of x is 2 by 3. Here 1 and 2 by 3 are called 0 of the polynomials. Means when x equal to 1, here f of fx is equal to 0. Let us put the value of x equal to 1. Then find the value. F of 1 is equal to 3 into 1 square. In place of x we can put 1. 5 into 1 plus 2, which is equal to 3 minus 5 plus 2, which is equal to 0. Here f of 1 is equal to 0. This shows that 1 is called 0 of the polynomials. When f of alpha is equal to 0, means fx, if fx is 0 at x equal to alpha, then alpha is called the 0 of the polynomial. Here another 0 is 2 by 3. This is a quadratic polynomial. Look at here. This is a quadratic polynomial. Here highest degree of the polynomial is 2. Then in case of quadratic polynomials, we find there are two zeros of these polynomials. Here another 0 is 2 by 3. Then f of 2 by 3 must be equal to 0. Let us try. Put the f of 2 by 3 means fx at 2 by 3. Put the value of x 2 by 3. In place of x you put 2 by 3. This is 5 into 2 by 3 plus 2, which is equal to 3 into 4 upon 9 minus 10 upon 3 plus 2. Then here 3 cancels. This is equal to 4 by 3 minus 10 by 3 plus 2. Then which is equal to 0. This means f of 2 by 3 is equal to 0. Take the LCM 3. Then this is 4 minus 10 plus 6. 6 plus 4, 10 minus 10, 0. This means f of 2 by 3 is 0. Means 2 by 3 is another 0 of the polynomials. Now let us discuss. We come to the conclusion that the quadratic polynomials have two zeros. Means the quadratic polynomial is the polynomial where degree of the variable is 2. In case of quadratic polynomials, we find there are two zeros in these polynomials. Now assume that the two zeros may be alpha and beta. Let us find the relationship between the two zeros. Relationship between two zeros of a quadratic polynomials. Let us find the relationship between the two zeros of the quadratic polynomials. Suppose fx is equal to, let us take fx is equal to 3x square minus 2x plus 5 is equal to 0. 5 3 ja 15. Yes. Now let this be a polynomial. This is also a quadratic polynomials. Now let us solve this. Use the middle factor factorizations. Split minus 2x into minus 5x plus 3x. Am I right or wrong? Look at here. We can split the minus 2x into minus 5x plus 3x. Recall the middle factor factorizations. The middle factor factorization shows that split the middle term in such a way that when we add, we get the middle term, and when we multiply these two terms, we get this is the product of the last two terms. Here minus 5x into 3x is equal to minus 15x square, when 5 into 3x square is 15x square. Sorry, this is minus 5. This is minus 5. This is minus 15x squares. Now take here x common. This is 3x minus 5. Then here is also minus 5. Then take 1 common. This is 3x minus 5 is equal to 0. Then this is 3x minus 5 into taking common these terms and into x plus 1 is equal to 0. Then here 1 0 is 5x equal to 5 upon 3, another x equal to minus 1. Here 5 upon 3 and minus 1 are two zeros of this quadratic polynomials. Now let alpha is the first 0, alpha is equal to, assume alpha is the 1 0 of the quadratic polynomials, another 0 is beta is equal to minus 1. Then there exists a relationship between two zeros of a quadratic polynomials, which shows that alpha plus beta is equal to minus b upon a, and alpha into beta is equal to c upon a. What do you mean by minus b upon a? Now let us write these two relationships here. Here two very important things. Alpha plus beta is equal to minus b upon a, and alpha into beta is equal to c upon a. This is the relations between two zeros of a quadratic polynomials. Then here what do you mean by a, b, c? Here a is equal to coefficient of x square, because this is the zeros of a quadratic polynomials. Quadratic polynomials is the polynomial of degree 2, means the highest degree of the variable is 2. A is the coefficient of x square, where b is equal to coefficient of x, and c is the constant. Then the generalizations of quadratic equations, put this here, and now let us find out the generalizations of quadratic equations. Then generalizations of quadratic equations, fx is equal to ax square plus bx plus c, where a is the coefficient of x square, b is the coefficient of x, and c is the constant. Then here when fx is equal to 3x square minus 2x minus 5, this means here a is equal to 3, b is equal to minus 2, and c is equal to minus 5. As for this formula, the relationship between two zeros, alpha plus beta is equal to minus b upon a, which is equal to minus of minus 2 by 3, which is equal to 2 by 3, and alpha into beta is equal to c upon a, which is equal to minus 5 upon 3. Here by solving this, we come to the conclusion that we get alpha is equal to 5 upon 3 and beta is equal to minus 1. Now let us put here this and prove the relationship. If alpha is equal to 5 upon 3 and beta is equal to minus 1, then alpha plus beta is equal to 5 upon 3 minus 1. Take the 3 as the LCM. This is 5 minus 3, which is equal to 2 by 3. Yes, we get this. Alpha plus beta is equal to 2 by 3. Now let us find out the alpha into beta. Alpha into beta is equal to 5 upon 3 into minus 1, which is equal to minus 5 by 3. Yes, this is this. This is alpha into beta minus 5 by 3, which is equal to C upon A. Then we can prove this relationship that alpha plus, students please be be concentrate here and so here and look at here. Alpha plus beta, very important thing, the relationship between two zeros of the polynomials. Alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Then by solving this, we prove this the relationship alpha plus beta and alpha minus beta, alpha into beta. Now take some more examples for better understandings. Take another examples. Here another example says that, take another example. Suppose here fx is given, here fx is given. Suppose fx is given cx 6x square. Look at here. Suppose fx is 6x square minus x minus 2, which is equal to 0. Now here also apply the middle factor factorization. 6x square minus 6 into minus 2 is minus 12. Then split minus x into minus 4x plus 3x minus 2 is equal to 0. Then take here 2x common. Then this is 3x minus 2. Then here minus 2. Then here take 1 common. This is 3x minus 2 is equal to 0. Then 3x minus 2 taking common. This is 2x plus 1 is equal to 0. This shows that 3x minus 2 is 0. X is equal to 2 by 3, 1 0. And another 0, 2x plus 1 is equal to 0. X equal to minus 1 upon 2. Then here alpha is equal to 2 by 3 and beta is equal to minus 1 upon 2. Then here this is the if we generalize the quadratic equations, here a is equal to 6, b is equal to minus 1 and c is equal to minus 2. Then according to the formula of relationship between two zeros, alpha plus beta is equal to minus b upon a, which is equal to 1 upon 6 minus of minus 1 plus 1 upon 6. Then alpha into beta is c upon a, which is minus 2 by 6, which is equal to minus 1 upon 3. Now here alpha is 2 by 3 and beta is minus 1 upon 2. Now let us find what is alpha plus beta. Here alpha plus beta is 2 by 3 minus 1 upon 2. Then taking 6 as the LCM. Then here this is 4 minus 3, which is equal to 1 upon 6. Look at here. Here also we find this is the alpha plus beta is also 1 upon 6. Here we find the alpha plus beta is 1 upon 6. Then we prove the relationship between these two zero. Alpha into beta is equal to 2 upon 3 into minus 1 upon 2. 2 cancels, which is equal to minus 1 upon 3. Yes, alpha into beta we also get here by using this formula is minus 1 upon 3. Then can we prove that the relationship between alpha and beta. Then now let us discuss some more examples for better understandings. Now let us take some more examples. I have already told you students, here we goes root we goes to the theory, to the root of the theory, and practice vigorous problems. Practice more and more problems. I have already told you, only knowing theory is not sufficient for maths. When you practice variety of questions, then it will be easier for you to attempt any questions which will be asked in your exam paper. Otherwise, the questions which will be asked in your exam paper will be a challenge for you. Here the question says that x square plus 7x plus 12. Here fx is equal to x square plus 7x plus 12. Now verify the relationship. Here you have to verify the relationship between alpha and beta. Here you have to verify this relationship. Alpha plus beta is minus b upon a, and alpha into beta is equal to c upon a. Then here a is equal to 1 and b is equal to 7 and c is equal to 12. Then according to the formula, alpha plus beta is minus b upon a, which is equal to minus 7 upon 1, which is minus 7, and alpha into beta is equal to c upon a, which is equal to 12 upon 1 is 12. Now let us find out the value of alpha and beta. Means let us find out the zeros of these polynomials. Look at here. Here fx is equal to x square plus 7x plus 12. Students, please do your worksheets and ask me your doubt. You may put your doubt in my comment box. I am ever ready to clear your all doubts. Look at here. Here also, this is, you apply middle factor factorizations. In case of middle factor factorization, split the middle term into two parts in such a way that when we add, we get the middle part, and when we multiply these two terms, we get, this is the product of first and third terms. Here I split the 7x into 4x plus 3x. Am I right? Then here take the x common, then you get, this is x plus 4. Then here you take 3 common, this is also x plus 4 is equal to 0. Here x plus 4 is the common term, take x plus 4. Then this is x plus 3 is equal to 0. Then you get the two zeros are x equal to minus 4. Then another 0, x equal to minus 3. Then here alpha is equal to, here you find alpha is equal to minus 4 and beta is equal to minus 3. Then alpha plus beta means, which is equal to minus 4 minus 3 is equal to minus 7, which is equal to minus b by a means minus 7. We can verify this formula. Then let us find out alpha into beta. Alpha into beta is minus 4 into minus 3, which is equal to 12. Yes, we verify. Then we easily verify the relationship between alpha plus beta and alpha into beta. Now students, you must practice your worksheets. Now take another examples. Here another example says that, fx is given here. Here in another examples, we also verify the relationship between alpha and beta. Here also fx is equal to 6x square minus 3. Then here a is equal to 6, b is equal to 0 and c is equal to minus 3. Then alpha plus beta is equal to minus b by a, which is equal to 0 upon 6 means 0. Then alpha into beta is equal to minus c upon a, which is equal to minus of minus 3 plus 3 upon plus c upon a. Sorry, alpha into beta is c upon a, which is minus 3 upon 6, which is equal to minus 1 upon 2. Now let us solve the polynomials to get the value of alpha into beta. Here 6x square minus 3 is equal to 0. Then take 3 common, this is 2x square minus 1 is equal to 0. This shows that 2x square is equal to 1, x square is 1 upon 2, x is equal to plus or minus 1 upon root 2. Then here alpha is equal to 1 upon root 2 and beta is equal to minus 1 upon root 2. Alpha is equal to 1 upon root 2 and beta is minus 1 upon root 2. Then alpha plus beta is equal to 1 upon root 2 minus plus minus 1 upon root 2. This cancels, we get 0. Here also we get alpha plus beta is also 0. Hence we verify the alpha plus beta is equal to 0, which is equal to minus b by a. Now let us find out the alpha into beta. Alpha into beta is 1 upon root 2 into minus 1 upon root 2, which is equal to minus 1 upon 2. Here also we get alpha into beta is minus 1 upon 2. Hence we verified the relationship between two zeros. Okay. Then here another problems. Here in these questions also you have to verify the value of alpha and beta. Students, when you practice variety of questions, then the questions which will be asked in your exam paper will not be a challenge for you. Here also the question says that here f of u is the polynomial which is equal to 4u square plus 8u. Here also you have to find out the relationship between alpha and beta. Then this is the students, please you pause the video and write down the questions and try to do your own. If any problem persists, then you open the video and see the solutions, but at first you must try to solve on your own. Then if any doubt, please ask me. I am ever ready to clear your all doubts. Here also when we generalize this polynomials, we get a is equal to 4, b is equal to 8, and in this case c is equal to 0 because there is no constant here. Then you know alpha plus beta is equal to minus b by a, which is equal to minus 8 upon 4 is minus 2, and alpha into beta is c by a, which is equal to 0 upon 4 is 0. Now here let us find out the value of the polynomials. 4u square plus 8u is equal to 0. Taking 4u common, this is u plus 2 is equal to 0. Then 1 0 is u is equal to 0. Another is u is equal to minus 2. Here alpha is equal to 0 and beta is equal to minus 2. Then alpha plus beta is 0 minus 2, which is equal to minus 2. Hence verified. Here also by putting this formula we get alpha plus beta is minus 2. Here also by solving and by getting the value of alpha and beta, we get that alpha plus beta is also minus 2. Hence the formula is verified here, and alpha into beta is equal to 0 into minus 2, which is equal to 0. Hence here also we get alpha into beta is 0. Hence here the formula is verified. Then now let us take another examples. Here also we have to verify the formula. Here another questions. I have already told you, when you practice variety of questions, the questions which will be asked in your exam paper will not be challenged for you. Here the question says that, here the polynomial says that fx is equal to 4 root 3. When you practice these questions, then you can factorize any questions which will be asked in your exam paper. Then minus 2 root 3. This is the polynomials given. Here when you generalizing these polynomials means a is equal to 4 root 3, b is equal to 5, then c is equal to minus 2 root 3. Then as for the formula, alpha plus beta is minus b upon a, which is equal to minus 5 upon 4 root 3, and alpha into beta, the formula says that alpha into beta is equal to c upon a, which is equal to minus 2 root 3 upon 4 root 3. upon 4 root 3 cancels, which is equal to minus 1 upon 2, which is equal to minus 1 upon 2. Alpha into beta is minus 1 upon 2. Alpha plus beta is 5 upon 4 root 3. Now let us solve the polynomials and find the value of alpha and beta. Here f of x is equal to 4 root 3 x square plus 5x minus 2 root 3 equal to 0. Now here also apply the middle factorizations. When we multiply these two terms, we get this is minus 24. When we multiply 423 and minus 223, when we multiply these two terms, we get minus 24x square. Then we must split the middle term in this way, that when we add, we get 5x, and when we multiply, we get minus 24x square. Then split in this way. This is the middle term split. If I split 5x as 8x minus 3x, I think I am right. Am I wrong? Can I split 5x into 8x minus 3x? Yes. Then from these two terms, take 4x as common. Then here left root 3x plus 2. Then here from these two terms, take minus root 3 common. Then you root 3x is left here, and here plus 2 is equal to 0. Then root 3x plus 2, root 3x plus 2 is the common term. Take root 3x plus 2. Look at here, students. When you practice more and more questions, then it will be easier for you. The questions which will be asked in an exam paper, this is not a challenge. You can easily factorize it, and you can find easily the value of two zeros, alpha and beta. Then when you find out the value of alpha and beta, then can you verify this formula very easily. Then here the 1 0 is x is equal to minus 2 upon root 3. Then another 0, x is equal to root 3 upon 4. Then these are two zeros. Here we get alpha is equal to minus 2 by root 3 and beta is equal to root 3 by 4. Now let us find out the alpha plus beta. To verify, we have to find out alpha plus beta. Alpha plus beta is minus 2 by root 3 plus root 3 by 4. Then take 4 root 3 as the LCM. This is minus 8 plus root 3 into root 3, 3. Then we get minus 5 upon 4 root 3. Look at here. This is minus 5 upon 4 root 3. This is minus 5 upon 4 root 3. This is alpha plus beta. Then finding the two roots alpha plus beta, we put the value of alpha plus beta, we get this. Hence we verified the first formula, alpha plus beta. Now let us find out the value of alpha into beta. Here alpha is this and beta is this. Then alpha into beta is minus 2 by root 3 into root 3 into root 3 by 4. Root 3 cancel, which is equal to minus 1 upon 2. Here also, look at here. This is minus 1 upon 2 alpha into beta. Here also, by putting the value of alpha and beta, we get alpha into beta is minus 1 upon root 1 upon 2. Hence we verified the formula the relationship between two zeros alpha plus beta and alpha into beta very easily. Now let us solve some more questions. Here another question says that find the zeros of the polynomials and verify the relationship between them. Here also questions given. Here also one questions. Look at here. Find the polynomials and find the relationship between two coefficients. Here another question says that this question is from your NCERT book. This questions here fx is given. Now students, please practice your book and ask me your doubt. Here the question says that fx is equal to x square plus 1 upon 6x minus 2. Then here a is equal to 1, b is equal to 1 upon 6 and c is equal to minus 2. Then alpha, according to the formula, alpha plus beta is minus b upon a, which is equal to minus 1 upon 6 upon 1, which is equal to minus 1 upon 6. And alpha into beta is equal to c by a, which is equal to minus 2 upon 1 is minus 2. Then now solve the questions. Fx is equal to x square plus 1 upon 6x minus 2 is equal to 0. Now here also use middle factor factorizations. Minus 2 into 1 is minus 2. Now split the middle term in this way that when we add we get 1 upon 6 and when we multiply we get now take the 6 as the LCM. This is 6x square plus x minus 12 is equal to 0. This is the question. 6x square plus x minus 12 is equal to 0. Then here split the middle term. 6x square, 6 into 12 is 72. Then I can split x in this way, 9x minus 8x. When we add these two we get x. When we multiply we get minus 72x square. When we multiply minus 12 into 6x square we get minus 72. Then split this. Then take 3x common. This is 2x plus 3. Then here also take minus 4x common. Minus 4 common. Then this is 2x plus 3 is equal to 0. Then here 2x plus 3. 2x plus 3 is the common term. Then this is 3x minus 4 is equal to 0. Here 1 0 is x equal to minus 3 by 2. Another x is equal to 4 by 3. This means here alpha is equal to minus 3 by 2 and beta is equal to 4 by 3. Now alpha plus beta is equal to minus 3 by 2 plus 4 by 2. Here 6 is the LCM. This is minus 9 plus 8, which is equal to minus 1 upon 6. Look at here. Here also we get by alpha in plus beta is minus 1 upon 6. Then here by solving this also we get this is minus 1 upon 6. When we find the value of alpha and beta and put the value of alpha and beta and we get this. Hence we verified the first formula, first relationship alpha plus beta. Now let us find the relationship between alpha into beta. Here alpha into beta is minus 3 by 2 into 4 by 3, which is 3 cancels, 2 cancels, which is equal to minus 2. Now look at here. Here also you get alpha into beta is minus 2. Then by finding the value of alpha and beta and put the value of alpha and beta we get alpha into beta is minus 2. Hence we verified these two formula. Alpha plus beta is minus b by a and alpha into beta is c by a. Now students, today this much. In my next class we will continue with this. Thank you students.